This time we're discussing herbicides, corresponding to Chapter 109 in Goldfrank's Toxicologic Emergencies. The learning objectives for this session are that you'll be able to explain the mechanisms of human toxicity from exposure to at least two herbicides, and identify at least one herbicide with specific indicated treatment options, as opposed to simply providing general supportive care. So what are herbicides? Herbicides are a diverse set of chemicals that disrupt plant metabolism and growth, resulting in death of the plant. I'm a sucker for chemical structures, so I'm providing a set of them here. There are very many herbicides, but I'm only going to mention what I consider the high points of those few that are covered in more detail in the chapter in Goldfrank's. Paraquat is a bipyridyl herbicide that is not only toxic to plants, but is also very toxic to humans. 10 to 20 milliliters of a 20% solution can be fatal. Once ingested and absorbed, Paraquat concentrates in the kidney and lungs, and its mechanism of action is to generate oxygen-free radicals. There's a redox cycle that occurs where the Paraquat goes back and forth between its usual form and as a Paraquat radical. And with each cycle, it converts a molecule of oxygen into O2-, a superoxide radical. That elaborates other reactive oxygen species and causes tissue damage, which sets up an interesting situation where the patient's lungs are being damaged and they might have an increased oxygen requirement, but you'd like to limit the amount of oxygen you're exposing the patient to because it may compound the pulmonary toxicity. Of the dangerous herbicides, severe paraquat poisoning is, unfortunately, common enough that nomograms have been developed to predict who might develop fatal toxicity. This isn't something that comes up often, and I don't expect you to memorize anything here, but the general principles of a nomogram, as we've learned with, say, the Rumack-Matthew nomogram, apply here too. The higher the paraquat level, the later after exposure, the worse the patient is expected to do. Diquat is another bipyridyl pesticide that shares the same mechanism of generating superoxide radicals, but compared to paraquat, Diquat is less toxic. And because it doesn't concentrate in pneumocytes, it doesn't cause the characteristic lung toxicity that paraquat does. But the common mechanism produces non-specific cellular necrosis. Clinically, this will most commonly result in damage to exposed mucous membranes in the GI tract, and also causing kidney injury by inducing acute tubular necrosis. Glyphosate is the most commonly used herbicide in the United States, and it's the second most commonly used in the domestic sector, around the home as opposed to use in agriculture. Although it's great in killing plants, glyphosate has very little toxicity in mammals. But we do see toxic effects when somebody ingests, say, Roundup, which contains glyphosate. And the toxic effects that do occur from glyphosate exposures are probably due to the surfactant that is co-formulated in the products we use. The most likely reason you may have heard about glyphosate is that there is ongoing debate as to whether it's carcinogenic or not. The EPA, the Environmental Protection Agency in the United States, says that it's probably not, while IARC, the International Agency for Research on Cancer from the World Health Organization, says that it is a carcinogen. Phenoxy herbicides are also commonly used in the US, especially in domestic settings where they're number one. Here's an example of perhaps the most common phenoxy herbicide called 2,4-dichlorophenoxy acetic acid, or 2,4-D. There's a particular toxidrome caused by 2,4-D, comprised of irritation or caustic effect on the exposed GI tract. It can cause an elevated body temperature, hyperthermia, believed to be due to uncoupling of oxidative phosphorylation, and it has neuromuscular toxicity, causing myotonia and potentially resulting in rhabdomyolysis, an elevated serum creatine kinase from skeletal muscle breakdown. It has been recommended for treatment of 2,4-D poisoning to alkalinize the urine with sodium bicarbonate to increase renal elimination. Hemodialysis has also been suggested to increase elimination. You may have heard of Agent Orange, which was one of several defoliant agents identified by color code names that were used by the US during the war in Vietnam. Agent Orange was a mixture of 2,4-D and 2,4,5-T, 2,4,5-trichlorophenoxy acetic acid. The map in the upper right shows those areas in red that were subject to aerial herbicide spray missions in southern Vietnam, and you can see that they were used pretty extensively. Since Agent Orange is a defoliant, it will cause loss of leaves, making it easier to locate opposing forces, decreasing the ability to hide in the jungle or among other plant life. And if there was only 2,4-D and 2,4,5-T in Agent Orange, there might not be such a major ongoing problem. But Agent Orange was contaminated with dioxin, which is a very environmentally persistent pollutant, which is alleged to induce a number of chronic health conditions and maybe cancer. Atrazine is an example of one of the triazine herbicides. Atrazine is the second most widely used herbicide in the US after glyphosate. We don't know its mechanism of toxicity in humans, but it may be from uncoupling of oxidative phosphorylation. And lastly, we'll mention propanil. Propanil toxicity is primarily due to its metabolites, which are aniline and amine oxidants, which will oxidize hemoglobin into methemoglobin. And that's all I have about herbicides. I'll be seeing you around.